that's what we covered in the first example, and then we started to apply that to a few different questions. Okay. Well, how are we going to move to the next part? Assuming v is less than 0, we'll come back to that in a second. Find x as a function of time. So now we are going to deal with time, right? Which is why you've got this initial condition here. Okay. So what is x as a function of time, right? Well, we want to integrate v, right? That's how we usually do it. Integrate with respect to not x, but t, okay? Because that's what relates displacement and velocity. So therefore, I'm going to have to say, what's v equal to, right? Well, if you take the square root of both sides, ordinarily we'd have to say, I'm going to have a plus or minus on this side, okay? But they give us this condition. Now, sometimes it won't be, actually, usually it won't simply be so neat that they say, look, assume these values for v. There will be some kind of detail in the question, like the way that gravity is acting or how someone has thrown a ball, which will tell you v has to be positive or it has to be negative or something like that in a particular domain. So I'm going to just take the negative value. Okay? So I'm going to get minus the square root of 2x cubed as v is less than 0. Okay? As usual, it's critically important that you actually state the reason why you're excluding an answer. Right? Okay, now what am I going to do with this? What can I do? Is there much to do? Okay, so my relationship, the one that I'm after, right, is relating displacement, I didn't do, with time. Okay, that's why I'm going to get x as a function of time in a second. Okay, so I know that velocity is displacement over time, so I've got this so far, and I'm going to break this apart. It'll be a little easier to work with. X cubed, take the square root. So what index am I after? 302. Good. Let's see if we can make this last, right? Now, pause for a second. Integrating at this point is going to be problematic, okay? Because what you've got over this side, that's okay. That's dx. I can integrate that, and I'm going to be with respect to time. But what you've got on this side is not with respect to t, right? So whatever I get after I integrate this, just as it is still going to be in terms of x's, right? So what can I do here? Any suggestions? Any thoughts? Now, if you remember, and this was something we dealt with in rates of change and also this morning, right? That the whole idea behind these derivatives and chain rule is that you can just sort of mix and match and throw these around just like any other piece of algebra, right? They do follow some other weird rules, but by and large, you can manipulate them. You can multiply and divide them just like anything else, right? So therefore, what I'm going to do is take the reciprocal of both sides. Okay, so I've got dx on dt, so I'm going to flip it upside down and call it dt on dx. Okay, now you flip one side, so you've got to flip the other as well, right? So minus root 2, that's going to become minus 1 on root 2. That part's flipped. Now this x to the power of 3 on 2, because it's already in index form, right? I could make it 1 over x to the power of 3 on 2, but we know how to deal with indices, if we want to flip things upside down. How am I going to change the index? Yeah, just slap a minus sign on it, right? Change the sign, cross the line. So it's like it's upside down. So I'm going to make that so. Okay? Now, I wonder how many of you can see, if your cogs are turning, and you can see where this is headed, okay? Remember, I want x as a function of time. Okay? I've got all the pieces here. I've got time, I've got my x's, it's just not quite in the right spot. What should I do? Now remember, these differential operators and stuff, we can move them wherever we like. Where would be the best place for our dt and our dx? Where should we put them? Okay? Now, I'd recommend that you've got x's over here, so the dx probably belongs over with the x's, right? So I'm going to leave the dt there, dt, okay? And I'm going to cut the dx over the other side. Minus 1 on root 2, x to the power of that, dx. Okay? Now here's the fun part, okay? I've got everything I need. I've got x's on this side, t's on that side. I'm just going to integrate the lot, okay? Integrate this side and integrate this side. Now the cool thing about this, what just makes it work, is that seeing as I'm integrating and I've got a differential operator here, and I'm integrating with 1 here, right? You differentiate this side with respect to t, you differentiate this side with respect to x, okay? Let's do the x first, because I think we know how to handle this. Don't worry too much about the minus 1 over 2. It's just a constant, okay? If you're going to integrate this, x to the power of minus 3 over 2, what do you do with it? What's the first step? Okay, I'm going to increase the power, right? You're differentiating, you're doing it in reverse, okay? So since you normally bring the power down, I'm going to bring it up. So x to the power of minus 1 over 2. I've increased it by 1, okay? But that's not all I have to do in order to integrate. What else have I got to do? I'm going to have to divide by the power that just went up there, right? Which is minus 1 over 2. Okay? That's a bit awkward because that's a fraction, but we'll deal with that in a second. Now, I'm going to have my minus 1 over 2. It's still there. Hasn't disappeared. Okay? And because it's an indefinite integral, I'm going to need some kind of constant here. So I forgot to call that C1, so I guess I'll call this another letter. So we'll call that D for a constant. Alright? Now, I've integrated the right-hand side, but I haven't touched the left-hand side. Now, it looks weird, I admit, but you guys totally know what to do with this, right? Now, in case you can't quite see it yet, right? There's a number hiding this. It's why I put this suspiciously large gap there so that I can put this in for later. That's a 1 hiding there, right? It's a constant, okay? So if it was, say, like 3 dt, you would know you integrate it, you get 3t. Well, it's 1, so you're just going to get 1t, okay? Now, I know that's an indefinite integral, so it should have a constant with it, right? But a constant and another constant, still a constant. So 1's enough, okay? Okay, now, this is really cool. I'm almost there, right? Remember what we were after? X is a function of t, okay? I've got t as a function of x. So all I really need to do is just rearrange and make x the subject, okay? So let's clean up this awful mess here. Negative, negative, they're going to cancel, so I'm going to get a positive here. 2 is going to come up here, right? I'm dividing by a fraction, okay? So this 2 should really belong here. 2 divided by root 2. What's 2 divided by root 2? It's just root 2, right? So root 2, that's my constant, okay. And then you're left with this guy, x to the power of minus a half. Now the half makes it a square root as well, and the minus means it's on the bottom, okay? So you got minus 2 on root x. Is that okay? That's time. Now at this point, I could continue rearranging and make x the subject, but it might be useful for me to actually find out what this constant is first, okay? So how do I find it out? What am I going to use? I need to get rid of time, I need to get rid of x, right? So that's where this initial condition comes in, okay? So I'm going to say, therefore, at time 0, left-hand side 0, I'm going to get root 2 over the square root of 1. That's the point at which it starts, so square root of 1 plus d. So root 2 on 1, so d, the constant, is minus root 2. You happy with that? Okay, this thing is dying rapidly. Let's try and finish off. So if d is negative root 2, I'll bring that back here. Time is root 2 on root x minus root 2. So now I just have to do the little work to get x on its own, right? So kick the root 2 over. I'm going to get this. Actually, I should have just left it where it was. T plus root 2 equals that. Okay, so this denominator here and that numerator, I'm just going to swap them around. So root x, root 2 on that. And now I just square x. Ta-da! Alright, now, there were some tricky things in there, so let me review, okay? After you've done the simple part, okay, which is work out v squared, okay? In order to move further and say, well, I'm going to get displacement, okay, you've got to integrate, so therefore you've got to deal with v, not v squared, alright? So that's where this condition comes in. But then furthermore, when you're moving forward these steps here, you got to flip that. That's a tricky part, okay? That's hard to remember. And it's also hard to execute properly, okay? There's lots of little traps in here where the numbers can just screw you over. You forget to flip something or you forget to make something negative. You have to be very cautious there, okay? But after that, it sort of just punches out. Now, part C. I want you to have a think about this one, okay? I really like it as a question because there are 3 totally different valid ways to answer it, okay? And I'm going to give you all 3 at the end, but I want you to try and think of how would you explain, I mean, we just assumed it, that V must be negative, okay? Well, can you say why? And in fact, like I said before, the question will often not tell you, assume it. You have to work out that it is this, and then use that as the basis of your solution, okay? So, how? What's your explanation? All right? I'll give you maybe 5 minutes to have a think about it.